In the name of God. Hello, dear students. My name is Masoud. I'm a physics teacher. We are in Ferho's website at your service to present the lectures about physics grade 10. Actually, in previous lectures, we talked about the whole chapter. We talked about the whole section 2 from chapter 1. We explained significant figures. We explained the rule for rounding. We explained the, let's say, rounding for multiplication and division and subtraction and addition. Right now, we are going to what? We are going to solve the question or problem of section review 1 to page 19. Let's dive in with the lesson. About the first question number, which SI units would you use for the following measurement? Determine the SI unit, convenient for each case actually. A, the length of a swimming pool. The length of a swimming pool is measured in meters. B, the mass of the water in the pool. The mass is kilograms. Yeah. C, the time it takes a swimmer to swim a lap. There's a swimmer. He or she swims the lap actually. So the time actually is measured in second. Let's move on to question number 2. Express the following. We have a conversion here. Express the following measurements as indicated. Actually, we want to express the first one, 6.2 20 milligram. We want to convert to kilogram. I told you in this situation we have two prefixes in both sides. It takes more than one step. Firstly, without thinking, just write the value of milli. Milli becomes 10 to the power negative 3, right? So gram remains as it is. Let's say the calculation has one more step right now. We want to convert gram to kilogram. You convert from small to large. That's why the exponent should be negative. Take the power from kilo, it will be 10 to the power 3, but you have to add negative because you convert from small to large. You have to add negative sign instead of the in front of the exponent, and after that you rearrange the number, the calculation, 6.2 multiplied by these numbers. Actually, we have let's say two numbers with one base. We have a common base here. Write one of the bases and add the exponents together. The answer will be 6.2 times 10 to the power negative 6 kilogram. I want to recall this note actually for you. I don't use conversion factor. I prefer this approach. In my opinion, this one is easier than using conversion factors, let's say factor, especially for students. And if you are satisfied with conversion factor, no problem, use it. So the most important thing is the result. If our results are equal, no problem. Any way you choose, any way you use, no problem. About B, we want to convert 3 times 10 to the power negative 9 second in millisecond. We want to convert second to millisecond. Because only in one side we have prefix, that's why it takes only one step. Here you convert, let me change the color here. You convert from large to small because second is much larger than millisecond. That's why you have to use positive powers, positive exponents. But let's say you took the power from the milli. Milli is the 10 to the power negative 3. But you have to remove the sign because you convert from large to small. That's why this is the answer. Write one common base here and add the exponents up together, and the answer will be 3 times 10 to the power negative 6 millisecond. About the last one, C, 88 kilometers, we want to convert it to meters, kilometer to meter. So from large to small as well, like this one, kilometers to meters. Here, just write the value of kilometers without changing the sign, because let's say the question is, the situation is satisfied here. It doesn't need to change anything, right? So everything is provided here. 88 kilometers, we want to convert it to meters. Kilo means 10 to the power 3, and that's it. 88 times 10 to the power 3 meters. That's it. Let's move on to another question. Question number 3. It's about it's about accuracy and precision. Question number 3. The following students measure the density of a piece of lead 3 times. The density of lead is actually 11.34 gram. 11.34 gram per cubic centimeter. This is true value, yeah? True value, or I told you, you can say, let's say, main value, true value, yeah? Considering all of the results, which person's results were the accurate? Actually, which person's results were accurate? Which one's precise? Were any both accurate and precise? So it means we want to check the accuracy and precision. Let's check them together. About the first one, so real value or true value, this one, I isolated for you here. Right now we have real value here. About the readings of Arin. Arin is a student. She mentions some. She measures some readings actually. About the accuracy, I don't say anything. Guess the guess the answer. Think about the accuracy. Accuracy means comparison between the true value or real value, comparison between real value and the measurements, one by one. Look here, 11.32 versus 11.34. They are very close to one another, right? So we accept this one. We accept this one. Number 2, 11.35, the second one, 11.35 versus 11.34. They are very near to one another, so we accept it. The last one, 11.33 versus 11.34. They are close to one another. That's why they are accurate, yeah? The readings are accurate. Till now, it's accurate. Let's study precision. I told you precision means comparison between the measurements among themselves, right? Like what? So ignore the true value. Don't care about true value in precision. In precision, focus on the readings only. 11.34, let me erase this. 11.32 compared to the 11.35. The difference is only 3 decimal places. They are very close to one another. 3 decimal points, yeah? They are very close to one another. 11.32 versus 11.33. They are very close to one another. 11.35 versus 11.33. So all of the readings are near to one another. That's why they are precise. So the reading is accurate and precise. About B, Cordine is another student, measures some, let's say, measurements. He has some readings actually. He or she, I'm not sure whether it's a girl or boy, I'm not sure whether it's he or she, male or female. 11.43 compared with the true value, right? Compared with this one. So it's away from the true value. It's, let's say, very far from the true value. In this situation, this is the first one. But by one reading, you cannot decide whether the, let's say, reading is accurate or not. The second one, 11.44. It's very far from the 11.34. It's 10 points, yeah? 10 points are, let's say, are different from one another. 11.42 versus 11.34. So all of the readings of Cordin are, let's say, away from their true value. That's why the reading is inaccurate. They are inaccurate, right? Let's move on to the precision. I want you to determine the precision here. Let me change the color for you. 11.43, 11.44. I'm talking about the precision. That's why I compared the measurements with one another, not with true value. Ignore true value and precision. Focus on the measurements, let's say only. 11.43, 0.44. They are very close to one another. 11.43 versus 11.42. They are very close to one another. What do you say about this one? 11.44, 11.42. So all of the readings are close to one another. That's why the readings are precise. Inaccurate but precise. Why inaccurate? Because they are far from their true value. Why precise? Because they are close to one another. Let's move on to another one. Berzin. We have Berzin here. Let me read the readings of Berzin. Berzin measures 11.55, 11.34, 11.04. Tell me about think about it. I wanna study the accuracy. I have to compare what? I have to compare the reading with the true value. 11.55, it's away from, let's say, from the true value. That's why it's till now it's inaccurate. But I told you only with one reading you cannot decide whether the reading is accurate or inaccurate. Let's study other readings. 11.34. It's the exact copy of true value. That's why we accepted, no problem. Let's move on to another reading. 11.04. So that's why, because 11.04 is very, very, very far from the true value. That's why this reading is not accurate. What do you say about the precision? Precision, comparing between themselves, comparing the measurements between one another. 11.55, let me erase this train. 11.55 versus 11.34. They are very far from one another. 21 points are, let's say, far from one another. 11.55 versus 11.04. It's like this one. It's the previous case. That's why they are very far from one another. What do you say about 11.34, 11.04? So I can say all of the readings are far from one another. That's why they are non-precise. So the readings of Berzin, the person was not accurate, was neither accurate nor precise. What does it mean? The reading is inaccurate and non-precise. Let's move on to another question. Perform these calculations following the rules of significant figures. Right? We want to perform or do these calculations. After that, let's say we round them. Either we round them up or down based on the result, according to the rule. I told you, the process is not randomly. Rounding is taking place. Let's say rounding is a systematic process. It's not random process. You have to obey these rules, yeah, some certain rules. So about the first one, we have multiplication. I want you to think about the rules for multiplication and division. 26 multiplied by 0.020, let's say 2584. After the calculation by your calculator or by hand, no problem. If you calculate it, you have this result, yeah? You get this result. So you get this number after calculation, 0.67184. In this situation, we want to round it, right? But round it to how many sigfigs actually? How many sigfigs? I told you in the case of multiplication and division, you have to concentrate on the number or figure with what? With the least significant figure, with the minimum sigfigs. So which one has a minimum sigfig? Actually, this one. How many sigfigs are there in this number? 2. So the answer should involve what? The answer should involve only 2 significant figures. That's why we need this part only, right? We need this part. 2 significant figures after the decimal. That's it. This is the answer. It will be 0.64. 67, excuse me. B, 15.3 divided by 1.1. We obey the same rule as the multiplication. Multiplication and division have the same rule, yeah? They have the same rule. 15.3 divided by 1.1. The answer after calculating actually, you get 3.9. This is the result, right? Focus on the number with the least significant figures. Which one has the least significant figure? Actually, this one, yeah, because it involves only 2 sigfigs. Here it has 3 sigfigs. Actually, our answer involves 3 sigfigs, right? But we need, let's say, 2 sigfigs like this, for example. We need these numbers. Shall I write 13? Shall I drop 9 without changing the penultimate or not? So you have to obey the rule. In order to, let's say, obey the rule, you have to drop this one, drop 9, and add 1 unit to the what? To the penultimate digit, to 3, and the answer will be 14, right? About the last one, excuse me, it's before the last one, we have 2 more questions. 782.45 divided by 3.5328. After calculation, actually, you get this result, right? You get this result. Here we have subtraction. In the case of subtraction and let's say addition, we obey a different rule. The situation is different from the multiplication and division. Here you have to focus on the number with the least decimal places, not least significant figures. Which of these numbers contain least or minimum significant, minimum decimal places? This one, yeah? This one contains only 2 decimal places. That's why the answer should contain, let's say, should contain 2 decimal places, right? So after calculation, you get this result. I told you, you have to have 2 decimal points after the decimal, right? The answer will be what? We need this one. How many significant figures are there here? Actually, I told you, you have to have 2 decimal places after the decimal. So we need this part. Only we need this part. These figures, yeah, these numbers. Let's say drop 7, no problem. I dropped 7. Is the situation round up or round down? Actually, the situation is round up. That's why whenever you, let's say, drop the 7, you have to add 1 unit to the 1, and the answer will be what? 778.92. This is the last answer. About the last example, we have an addition. 63.258 plus 734.2. After calculation, actually, think about it. What's the rule? Think about the rule. Which one has the least decimal places? So you have to focus on the number with least decimal place. In this situation, this one has the least decimal place. That's why the answer should contain only one decimal place, right? So we need this one. We need this part. We need these figures only. One figure after the decimal place. One figure. In this situation, like the previous cases, we have round up. We drop the 5 and add 1 unit to the 4, and the answer will be 797.5. That's all for today. Thanks for watching this video.